So today we will be covering an implementation of Xcos of a full wave rectified sine wave using a Fourier series approach. So let's have a background first. So Scilab is associated with a program feature called Xcos that can be used to model and implement various system behaviors. Models can be designed, loaded, saved, compiled, and simulated. Also, it is an alternative tool for MATLAB since this tool is an open source tool, unlike MATLAB wherein you needed license to operate. Scilab is free. So in this section, Xcos will be used to implement the following equation, which represents the first 5 terms of Fourier series of a full wave rectified sine wave signal. So we have v as a function of t 2 over pi minus 4 cos omega t over pi 3 minus 4 cosine 4 and so on and so forth. So given a frequency of 60 Hz in this implementation, so you have radian frequency is equal to 2 pi f 2 pi times 60. So the full wave rectified sine wave indicates the need for the following Xcos block. First, a constant block with value of 2 over pi. Okay. Then a sine wave block. A cosine is implemented by using pi over 2 radians. Use a sample time of 0.01 millisecond. And various gains for the multipliers are 4 over 3 over pi, negative 4, 3 over pi, negative 4, 5 pi, negative 4, times 35 over 35, okay, and sum block and sum scope, okay. As a continuation, let us show how to implement this Fourier series waveform, full wave rectified sine wave in an Xcos. So you will expect to implement this model here as shown in this figure. So first, go to Scilab. Where's the Scilab? Go to Scilab. Then go to application, then click Xcos. And that you will see a palette browser. So if the palette browser is not shown, you can go to view, then click palette browser. Then add the necessary blocks needed for the full wave rectifier sine wave. So what do we need here is the sine wave block, and you can copy it by just having copy, then paste and all like that. Then you can modify it according to the specification given in the text or in the problem, and the radians also. Then also add the clock. A clock is necessary for the scope, and also the what else? The summation, then the gain block. Also, what else? And the scope. Okay, so that is some of the following blocks needed to implement the full wave rectifier waveform. So I will show you here some waveform that I implement prior. So I have it here. So this is a Fourier series with a frequency of 60 Hz. So I label it according to its number of number, okay. And also I add the necessary gain. So for the first gain, for the first sine wave, we have negative 4 over 3 over pi. And for the sine wave, also we have it here, the frequency and the radians or the phase, because the full wave rectifier is shown as a cosine wave. To convert it into sine wave, the phase must be in pi over 2. Then I add some of the scope. I use the single scope to show you the respective view of each waveform instead of using the multi-scope, wherein the waveforms will be shown in one figure only. Okay, so after having that implemented, simulated, just press the play button here, and so after that, if you are satisfied with the waveform, then you can now stop. Actually, it already stopped. So the waveforms are shown here as expected. So we have 1, 2, 3, 4, 5, 6 scopes. So one scope for the constant, and for scope 2 wait for the sine wave, then scope 3 and 4 and 5 and 6. So it can be shown as expected in the waveforms that the waveforms for the sine wave, as number of components are added, so makita ninyo nga magkagamay ang waveform nga value kung magkataas. Just like for example for scope 5, nagkamay na siya ang iyahang value. And also, adding it up together, we have the scope 6. Okay, so I expected you to do this in the same manner, but the frequency will be differ. You will be using a 120 Hertz this time for a full wave rectified sine wave signal. So I'll be forwarding this source here file so that you can modify and practice it in your home. Okay, and also kindly submit it in the in your Microsoft Word. Submitted in Google. Okay, I'll just post it later where to submit it. Okay, bye.